All right, let's see if this one actually lets me get all the way through it. So we're going to do practice problem number 3 associated with sample problem 3-5. Okay. And the thing I want to get across in this practice problem is that there's nothing new here. This isn't anything new. This is actually using the same skills that we've had up to this point. We're just going to do it twice. That's really all we're doing. But I imagine if you're having a tough time getting started on this problem, it has more to do with simply getting started. And that's where students really struggle with this type of problem. How do we get started? So let's pay attention to what the question has to offer us here. What mass of gold, okay, so talking about mass in grams, that's what we know how to convert out of and into, grams, of gold contains the same number of atoms as 9.0 grams of aluminum. And so you're thinking, especially comparing this problem to the previous few sample problems and practice problems, thinking, okay, well, I got to convert from grams into grams. What doesn't make sense? Okay, how do you convert grams into grams? And then you might be thinking, well, you're converting from aluminum into gold. Okay, you're getting a lot closer there, But even though you're very, very close to what we need to be doing, let me ask you, how do you convert from aluminum to gold? So let me point out one part of this question that is very important. Same number of atoms. That's going to be incredibly important here. It's got to be the same number of atoms. So what that means is however many number of atoms is present in 9.0 grams of aluminum, that's the number of atoms we're talking about. So the question is, how many atoms are in 9.0 grams of aluminum? So we can definitely do that. So we can go from grams of aluminum and convert out of grams of aluminum into moles of aluminum. You might be wondering, why are we converting into moles of aluminum when I want to get to atoms of aluminum? Well, remember, like in practice problem number 2, we don't have a statement of equality that allows us to go straight from grams to atoms. We can convert from grams into moles and then moles into atoms, but it's a 2-step process. So now my grams will cancel, and now I can focus on converting out of moles of aluminum and into atoms of aluminum. Moles will cancel, and the only unit that I'll have left is atoms of aluminum. Now, once we have that number, okay, once we have that value, we can take that value and start a new set of conversion factors, but now we'll be talking about gold, right? Because it's the same number of atoms. Okay, so however many atoms of aluminum we have, right, this number, same number of atoms of gold. So we can start a second conversion down here, atoms of gold, and we can convert out of atoms of gold and into moles of gold. And then finally out of moles of gold and finally into grams of gold, which is what the question is actually asking for. Because atoms will cancel with atoms, moles will cancel with moles, and the only unit we'll have left is grams of gold. Now, I'm ready to start plugging in values. First off, what does the question give me to start here? I'm starting with 2.0 grams, right, from this part of the question. I like to point out that this has two significant figures. So when I go to report my answer, finally, I'm going to need to consider two significant figures. The in-between parts, it's not quite as important, but when I go to box out my final answer, I need to have two sig figs. And, looking at the periodic table, I see that 1 mole of aluminum has a mass of 26.98 grams. I know that 1 mole of atoms is Avogadro's number of atoms. And when I actually do the calculations, again, to two sig figs, ends up being 2.0 times 10 to the 23rd atoms of aluminum. So this number of atoms, okay, same number, that's what the question says, same number of atoms, but now gold. So I'm going to take this number, I'm going to slide it over here. Hopefully, am I getting off the screen here? Let's see how far I can go. So 2.0 times 10 to the 23rd. I think that's not showing up fantastically on the screen, but we got to do what we got to do. So I've taken this value and I put it in here, atoms of gold, right? Because it's the same number of atoms, Well, now I can just set up these conversion factors like I'm used to at this point. 1 mole of gold has Avogadro's number. That doesn't look great. Has Avogadro's number of atoms. And 1 mole of gold, if I look at the periodic table over here, that's 196.97 grams of gold. And when I plug this into my calculator, remember, I need to consider two significant figures for my final answer, or else I'll get dinged a little bit. It was 65 grams of gold. So again, none of this stuff is brand new. Okay, this is not unique to number 3. We already did these types of conversions, right, using Avogadro's number and the molar mass of an element. We already did that in practice problem 1 and 2. The only difference here is we actually had to do it twice. That's what made it a little bit different in problem number 3, because we had to figure out how many atoms of aluminum were present in 9.0 grams of aluminum. Once we knew the number of atoms, we therefore knew the number of atoms of gold, because again, question said same number of atoms. And then we could start another conversion process and convert atoms of gold using, again, Avogadro's number and the molar mass of gold from the periodic table. Consider the appropriate number of significant figures, and we come up with 65 grams of gold.